Hello. How are you today? This is Patrick Kamala. I'm a tutor and educator here at Rostec College Pulukwani. Yes, all my learners from Rostec campuses, wherever you are, I send you my greetings. Now, today we are doing projectiles, and this is a topic which is so interesting. Okay, so I encourage you to join us. We are going to be making our live videos as well, so you can join us on YouTube. Yes, now we are doing a series of videos. We already did Newton's laws of motion. Now we're doing projectiles, and we want to do this until you guys write. Okay, so now projectiles has got some terms and definitions which we need to know before we tackle it. So if you check here, this is what I have here for you. Now they can say define a projectile. A projectile is an object given an initial velocity in a motion that is only influenced by gravitational force only. Then they can say define free fall. We say free fall is motion during which the only force acting is the force of gravity. And they can also say draw a free body diagram showing the forces on the projectile. Now, projectile is only influenced by gravitational force, so we only have this big dot with only gravitational force because it's a projectile. So it is always facing vertically downwards. Now, in some questions, they can say that write down the magnitude and direction of the acceleration on the projectile. They can say at maximum height or anywhere during the trajectory. So it is always 9,80 meters per second squared vertically downwards. Okay, now this is from Free State 2024, as you can see it here. We are going to do it together. Now as we do, I encourage you to first do all the questions, and then later you mark yourself as you watch the video. So these are the questions here. You can first try them out, and then later you mark yourself as you watch the video. You try them out, and then later you mark yourself as you watch the video. Okay, so now all learners from all campuses of Rostec, you are welcome. We love you so much. We are behind your success. You know, Rostec, we are striving for excellency. Even right now, we found it easy to make your life so that you can get all the marks which you want. So now, as we do these questions, sit down, watch the video, pause, practice, and ask. You can inbox me on 0785 222 041. All right, we are starting right now. Now Gauteng, from Free State 2024, question 3. Okay, this is the question here. They say that a ball of mass 175 grams falls from a tree and breaks the glass roof of a wooden cabin directly below it. The ball continues to fall freely until it hits the ground. The velocity time graph below represents the motion of the ball from when it left the tree until it hit the ground. So on the y-axis I have got velocity in meters per second. Then here I have got the time in seconds. Okay, what do we do? 3.1. Define the term projectile. We have said a projectile is a body given an initial velocity whose motion is only influenced by the force of gravity. Next question. They say calculate the distance the ball fell from the instant that it left the tree until it hits the glass roof at 0.8 seconds. Calculate the distance the ball fell from the instant that it left the tree until it hit the glass roof at 0.8 seconds. So if you check here, 0.8 seconds this time here, this one here. Now if they give you a velocity time graph and you're looking for the distance, I want you to know that because distance is measured in meters, what we do, we find the area under the graph. So this triangle here, I'm going to find the area under this graph here. And now that area is going to be my distance traveled by this ball until it hits what? Hit the roof of the glass. Okay. Okay, now so now this being a triangle, this is 0.8, the base, okay? What about the height? It is 7,84. So I want to find my distance. So we select our distance, okay, which is the same as area, equals to a half, okay, times base times height. So in this case, it's going to be a half. Now the base here is 0.8 seconds. What about the height? It is 7,84. 7,84. So what do we get here? Calculators, we have a half times 0,84, okay, then times 7,84. So what do we get there? 0,5 times 0,8 times 7,84. Here I get 3,14. I get 3,14 meters. 3,14 meters. That's my distance. That's my distance now. Okay. Next question here. They say, for how long was the ball in contact with the glass roof? Now here at 0,8 it hits the glass, okay, and then at 1,0 it's bouncing, it is getting away from the glass, okay, getting away from the glass here. So you see this time lag, which I'm putting in red, that's what they are asking for. The distance between the ball is in contact with the glass and then it leaves the glass. So now how to get this time distance? We're gonna say 1,0 minus 0,8. So how long is gonna be? We say 1,0, okay, 1,0 minus 0,8. Which answer do we get here? We get 0,2. 0,2 seconds. Okay, next question they say, calculate the average net force acting on the ball while it was in contact with the glass roof. Calculate the average net force acting on the ball while it was in contact with the glass roof here, okay. Now if you look at our formula sheet, we know that we have a formula there which says that F net, okay, F net, okay, F net multiplied by change in time equals change in momentum. So we can say here equals to change in momentum divided by change in time, okay. I'm looking for the net force. So because this ball is not changing in mass, I'm gonna say that my F net, okay, my F net equals to what is change in momentum given by the mass, open brackets, final velocity minus what? Minus initial divided by change in time, okay. So what we get here? We know the mass of the ball is how many grams? Let's check it again. They said that the mass of the ball is 1.175 grams. So to put in kilos, you divide by 1,000, so it becomes 0,175. So here you're gonna have 0,175. So that's our mass, 0,175 to put in kilograms. So what about final velocity? The question says that calculate the average net force acting on the ball while it was in contact. So there was a change in the velocity during contact. So we have, this is the V final, which is 1,53. 1,53, okay. What about V initial? That's when it landed on the glass. So we say minus what? 7,84. Minus 7,84. Divided by the change in time, which we just got as what? At 0,2. Got at 0,2. So what's our final answer here? Calculators, we have on top, we have 0,175 open brackets, 1,53 minus 7,84 close bracket divided by 0,2. So our answer here is negative 5,52 newtons. Negative 5,52 newtons, okay. All right, which in this case we're gonna say because it's the force, the force acting on the ball or it was in contact with the glass. Ne? So it's gonna be 5, okay, comma 52 newtons upwards, because the ball was acting on the glass downwards. Okay, so this is our answer here. All right, next question. Let's check it out now. Let's check it out now. Yes, hello. I hope we are together. Next question says here that calculate the speed of the ball. Calculate the speed the ball reached when it hit the ground. Now, what do we have? The speed the ball reached when it hit the ground. If we check what we have here, this the time to hit the ground is 1,7 seconds. Now, according to what I have here, I can see that I have the velocity when the ball left the glass. Okay, and what velocity is that now? I see it is 1,53. Then I'm looking for the velocity when the ball hit the ground. I only know the time. So because the ball is going down, okay, and anyway, I see here the ball is going down, and these are positive values here. So it means my down is positive, okay? Down is positive. So my gravity is also positive what? Positive 9,8, okay? And then I see my velocity initial when the ball leaves the glass is what? It is positive 1,53, positive 1,53. And then the change in time, I can see here, it is 1,7 minus 1,0, which makes it 0,7, okay, 0,7. I'm looking for the speed when we are hitting the ground, that's the final, okay. If you check here, I don't talk about change in y, which means that all the equations of motion which contain a change in y, I will not use them. So I rather use v final, okay. V final equals to v initial plus a change in time. So here I'm looking for the v final, okay. My v initial, it is positive 1,53, 1,53, okay, and then plus my acceleration is 9,8 positive, okay. What about my change in time? 0,7. So which answer do I get here? So what do I get here? I can see with my calculator here that I get let me check it, 1,53 plus open bracket 9,8 multiplied by 0,7. It gives me here 8,39. So the change in time, the velocity is 8,39. 8,39 meters per second. Because they want speed, I don't put direction. Hope we are together. Next question here. They say that how does the magnitude of the force exerted by the ball on the glass roof compare to that of the force exerted by the glass roof on the ball? I repeat, how does the magnitude of the force exerted by the ball on the glass roof compare to that of the force by the glass roof on the ball? Now, we said Newton's third law of motion that if body A exerts a force on body B, then simultaneously body B will exert the same force on body A of the same magnitude but opposite direction. So here, the answer is going to be what? The answer is going to be equals to, because they said magnitude, ne? It's going to be equals to. So this force will be equals to, will be equal. Then they name the physics law and then explain to support your answer. The physics law is what? Newton's third law of motion. Newton's third law of motion. And then how do you explain it? We say that because if body A exerts a force on body B, then simultaneously body B will exert the same force. Now in the context we can say if the ball exerts a force on the glass roof, simultaneously the glass roof will exert the same force on the ball but in opposite direction. Okay, another question here from Gauteng. Now those learners from Rostec in Gauteng, yeah, this is what you did. We are raising it now. All right, it says here that a tennis ball falls freely from rest from point A, which is 44 meters above the ground. The time taken to fall to the different positions B, C, and D is given in terms of time t, as shown below. Okay, so it is from rest here at A, then at B, at C, and D. This is a ground here. Define the term free fall. What did we say? Free fall is motion of a body which is only what? Influenced by the force of gravity. Next question here. Calculate the value of t. They want the value of t. Now we see from the initial point, that is point A, to the ground, they are 44 meters, and our time given is in terms of t, that is 2t, t, and 3t. So to get our value of t, we have our displacement, and because the ball is being dropped downwards, to avoid confusion, I'm going to use downwards as positive. Okay, so I can say take downwards as positive, and when I do so, I can get my t like this. So if we choose down as positive, guys, if we choose down as positive, mean that now down is positive. Okay, down positive. So what do we know? We know gravity is now what? Positive 9,8. Okay, then we have our change in y, which is given as positive 44. Okay, what's going down? Okay, then our change in time is going to be the sum of these t's here. That is AB 2t. That is 2t. Okay, then plus what? Plus t, and then plus 3t. Okay, which gives us what? Which gives us 60t squared, 60t in total. So we're looking for the value of t. So because we have our change in y, and our v initial is 0, because it was from rest, okay, so we can say that our change in y from A to D, okay, from A to D equals to v initial, okay, times change in time, plus a half A change in time squared. So our change in y is 44, so we have 44 here, 44 here. The v initial is 0, then times 6t, then plus a half, okay, times 9,8, and then times 60t squared, so brackets 6t squared. So we have 44. Now 0 times 60t, we get 0, okay. What about here? You're gonna get 4,9 times 36t squared. We have 4,9, okay, times what? Times 36t squared, 36t squared. So to get our t, divide 44 by 4,9 and 36, then you square root. Okay, so what is our t going to be? We're saying square root, we divide what? 44 by 4,9 multiplied by what? By 36. So here it gives me 0,50. So my time t, my t is 0,5. My t is what? 0,5. Okay, all right. Next, what must we do? After getting to calculate the height of the ball at point C. Now I want the height of the ball at point C. You see point C, this one here, which is how many t's? Which is 2t, that is 3 t's from point A. So to get the height of the ball at point C, I'm gonna get the distance from A to C, then I subtract from 44. Okay. Now that I know my t, I'm going to find the change in y from A to C. Okay. So my change in y is given by v initial, okay, okay, times t, right? Yeah, v initial times t, okay, change in time t, plus a half, okay, plus a half, a change in time t squared. So now our change in y from A to C, okay, that's what we're looking for first. From A to C, Now the v initial is from A to Q, which was 0. Then 0 times t, our t is 0,5. Now our t here is from A to C, which is 3t. That means 3 times what? 3 times 0,5, okay, 0,5, then plus a half, okay, times acceleration, which is positive 9,8. What about our time? It is 3 times 0,5, ne? Which is actually 1,5, ne? 1,5, then must be squared. So my answer here for y from A to C is going to be what? Calculators, what do you get there? That is 0,5 times 9,8 times 1,5 squared. Here it gives me 11,03. 11,03. Now I want distance from the ground to C, so that distance CD, okay, equals to 44 meters, okay, minus 11, what, 03. So what do you get here? So 44 minus 11,03. So here it gives me 32,97. It gives us what? 32,97 meters above the ground. They wanted the height of C from the ground, né? That's how we get it there. Now they say something here that if after the first bounce the ball reaches point C, sketch the position time graph for the ball from the moment it is dropped until it reaches the point C after the first bounce. I repeat, if after the first bounce the ball reaches point C, sketch the position time graph for the ball from the moment it is dropped until it reaches point C after the bounce. Okay, now we know that our position is given by change in y equals to vi change in time plus a half at squared. Ne? Now because of that at squared, it means that our graph cannot be a straight line but must be a parabola. So now it's being dropped from a certain height, then it bounces and then to a certain height C. What must we indicate on our graph? Show the following: the time values at points D and C before the bounce in terms of t, and then also the heights at A and C. Take the ground as a point of zero reference, meaning that on the ground you must draw your 0. Okay, you must draw our what? Our 0 on the ground. So here we go. We are going to have our position time graph. Okay, position time graph like this. So here I draw my y-axis, okay, from this point here. This is my y-axis here, okay. All right, and then the time, like this up to here, position time graph, okay. This is time in seconds, okay. This is our change in y in meters, change in y in meters. And then here, they said indicate what? The time value. Now the ball was being dropped, so it gets from a certain height, there, which was 44. So it comes and hits the ground, then it bounces to a certain height C, somewhere here. Alright, so what must we show? The time value is at point D and C. Now at point D, we saw it was 6t. Okay, that's to reach the ground. So this is 6t. You want it in terms of t, that was 6t, you remember? Okay. And then also D and C. Now after bouncing, now the time from okay, they say D and C. Now from D to C, okay, they said time values at points D and C. Let's check it out properly. In terms of t at points D and C. In terms of what? In terms of t. So here where you see the 6t, here we are hitting the ground. Then from the ground to get to this point C, that's what we need there. Okay, so they want a time there. What is mass ratio? The heights at A and C. Now at A it was 44, so this is 44 here, this is 44 here. Then at point C, the corresponding height we are putting here, we got what? We got 32,97, okay? 32,97, this is what we have here. 32,97. Okay, what else do we need? If we look at the time values at points D and C, let's check it again. At point D, what do we have? From point A to point D, it is 60. And then from D to C, what is it gonna be? Because this is 60, what's gonna be at point C? This is 3T, right? So from C to D, okay, what do we have here? What's our time at point C? Anybody who has an idea? Now our T is what? Our T is okay, we have to solve it then. Alright, now our T, to get from what do we know? Our T to get from D to C in terms of T. This is 3T, which we have from C to D. Oh yeah, from C to D. So 3T plus 60, we get 90. Yeah, it must be 90 here by time symmetry, assuming we didn't lose any of the energy. Okay, next question here. This is now from KZN. Ball A is projected vertically upwards at a velocity of 10 meters per second from the ground, as shown in the diagram below. This 10 meters per second. Ignore the effects of air resistance. Use the ground as your reference. Explain the term projectile. So, what's a projectile again? We said it's a body given an initial velocity in motion, which is only influenced by the force of gravity. So, next they said that draw a labeled triple diagram indicating all the forces acting on the ball A just before it reaches its maximum height. Now, just before maximum height, it is a projectile. Like I told from the beginning that any projectile has gravitational force. So our free body is just this dot here. Okay, this dot here. The dot with what? With the force of gravity. So when you go down here, we have what? We have our Fg, the force of gravity. But downwards, so we put here our Fg. Next question. Write down the magnitude of ball A's kinetic energy at its maximum height. Now at maximum height, velocity is 0. And how do you find kinetic energy? Ek. Ek equals to a half, okay, times mass of the ball times velocity squared. But here at maximum height it is 0. Next it's going to be now a half, okay, times mass times 0 squared, which gives us what? Which gives us 0 joules, because of the 0 velocity at maximum height. Okay, next question here. This one here, question 3. Let me zoom. It says that object A is projected vertically upwards from the ground. It takes 0.8 seconds to pass a window which is 1.5 meters high and 8 meters above the ground. It strikes the balcony at a velocity of 1.5 meters per second and falls back to the ground. At the same time, object B is projected vertically downwards at a velocity of 8 meters per second. Ignore the effects of air friction. Okay, so I repeat, object A is projected vertically upwards from the ground. You can see it here. It takes 0.8 seconds to pass a window which is what? 1.5 meters high and 8 meters above the ground. It strikes the balcony at a velocity of what? 1.4 meters per second and falls back to the ground. At the same time, object B is projected vertically downwards at a velocity of what? 8 meters per second. Ignore friction of the air. Define the term projectile. What did we say? A projectile is a body given an initial velocity whose motion is only influenced by the force of gravity. What must we calculate now? Calculate the velocity of object A at the bottom of the edge of the window when moving upwards. Now object A moving upwards, I want velocity at the bottom of the window, which means at this point here. At this point here, okay. Now this window is 1,5 meters, okay. 1,5 meters. Now the distance is 1,5 meters, okay. Now because object A is going up, I will choose up as positive. Ne? So if up is positive, it means that my gravity becomes what? Gravity becomes negative 9,8 meters per second squared. What about my change in y? My change in y, it is 1,5, okay, also positive because I'm going upwards, 1,5 meters, okay. Then they gave us the change in time, which is they said that let's take it again. They said that it takes 0,8 seconds to pass a window, meaning to cover this 1,5 meters. And it takes how much time? 0,8. So here I have 0,8. I have 0,8 seconds. 0,8 seconds. What am I looking for? Velocity at the bottom. I'm looking for the V initial. If I consider the window now, I'm looking for the V initial. So what do I know? The formula says that our change in y equals to V initial times change in time plus a half, okay, then a change in time squared. So my change in y is 1,5, okay, 1,5, okay. Then my V initial is what I'm looking for, okay. What about my change in time? They gave us 0,8, so 0,8 here, then plus a half, okay, 1/2. Then gravity, we said negative 9,8, 9,8. What about our change in time? They gave us 0,8, so 0,8 here, but must be squared. So what's my time, my V initial? So this is 1,5 this side, okay, 1,5. So because of the negative in here, it becomes a positive. So 0,5 times 9,8 times 0,8 squared. What do you get, calculators? 0,5 times 9,8 times 0,8 squared. It gives me here 3,136, but now it's going to become positive this side. So plus 3,136 equals to 0,8 V initial. So now if I add and divide by 0,8 here, what's my answer? Plus 1,5 divided by 0,8. So my V initial becomes what here? 5,795. So the V at the bottom of the window, which I call a V initial, is what? It is 5, okay, 795 meters per second. That's my answer. What do I need next? They said that calculate the velocity with which the object A is projected from the ground. Now I need V from the ground, okay? Now because I have the V at the beginning of the window and I have my change in Y as 8, I can get my V initial, alright? So here I don't talk about change in time. I'm looking for the velocity from the ground, okay? So I said beginning here it is 5,795, okay. Looking for the V at the ground, I have my change in Y, so I can use VF squared, okay. I can use what? I can use V final squared, okay, equals to V initial squared plus 2A change in Y. So V final in this case is the 5,795. Is the what? Is the 5,795. but must be squared. I'm looking for the V initial on the ground, okay, and then plus 2a. Because we are going up and we chose down as positive, it means that we chose up as positive, so it means our graph must be negative 9,8. Okay, what about my change in y? It is 8. Okay, all right, so here I'm going to square the v final, then I add and I look for the square root to get my v. So I'm going to say this 5,795 squared, okay, and then plus, open bracket, that is 2 times 9,8, then times 8. Okay, all right, it gives me 190. So my v initial is gonna be the square root. Okay, square root of what? Of 190 comma 38 comma 38, which gives me what? Let's check it out here. Square root of this answer here, it gives me 13,80. 13,80 meters per second. Now this is my v initial here. It is 13,80. Okay, that's my answer. Okay, now here they said that I must do what now? Let's check it out here. What else? The height above the ground at which object A and B will pass each other. I want the height above the ground at which object A and B will pass each other. Now to know that height, where they're going to pass each other, let me first find the distance between the ground and the balcony. Because I have the V initial and they gave me the velocity when we hit the balcony. I don't know if you remember this one here. This is 1,4 meters per second. This one here is my velocity for hitting the balcony. So meaning I can find my distance from the balcony to the ground. Then I can take it from there. Okay, just like this. So I'm gonna say that for ball A, looking for this distance first, okay, so I'm gonna use v final squared, Can use what? V final squared, okay, equals to v initial squared plus 2a change in y. Okay, so v final is 1,4. Okay, 1,4 squared. The v initial will just go 13,80 squared. Okay, then plus 2a, this negative 9,8. Now I'm looking for this capital height h between the balcony and the ground. So what do we get here? Now 1,4 squared minus what? I'm gonna say 1,4 squared, actually minus 13,80 squared. Okay, then divided by what? Divided by negative 2 times what? Times 9,8. Okay, so it gives me what here? 9,62. So my h is 9,62. My h is 9,62 meters between the ground and the balcony. Okay, so now I want the distance when the balls pass each other. Let's check it again. Here. They say calculate the height above the ground at which the object A and the B will pass each other. Now let that height above the ground be small h. Okay, let it be what? Small h. Now remember that they were dropped at the same instant, so if that height is small h, okay, which I'm looking for, it means that that will be the height reached by the first ball, which is ball what? Which is ball A. Okay, so that's my change in y. So for ball A, what do I know so far? I know that my change in y for ball A my change in y for ball A will be that height h, okay? And then what do we know about the change in y? Change in y, okay, equals to v initial times change in time plus a half, okay, a change in time squared. So I'm gonna put my small h here, okay, that's for ball A, okay, then equals to v initial, which I got as 13,80, then times change in time, which I don't know, looking for that for now, then plus a half, that's 1/2, into negative 9,8, okay, then t squared. So if I simplify here, I can see that I'm gonna say my small h, okay, equals to 13,8 t minus 4,9 minus 4,9 t squared, okay. So that is my equation 1. Now look at the other ball now, which is from the balcony, okay. Now don't forget that we said let that height where they meet be small h, no? Let's put it somewhere here where they meet, this one here. Let's be small h from the ground, no? From the ground here, the small h, if they meet somewhere here, okay, the small h, our small h here, okay. Now if that's our small h where the two balls meet, no? It means for ball B, from the beginning point to this height h, I'm gonna say what? Because B is going down and I chose up as positive, my ball B's change in y is going to be what? Let's check it here. Change in y for ball B is going to be negative, open bracket. Now this is between balcony and the ground, we got 9, what? 9,62, right? Let's check it here. 9,62. So I'm gonna put here, I'm gonna say negative 9,62, okay, 9,62, then minus the height, small height. So it's gonna be now the small height minus 9,62 as my change in y, okay. That's for ball what? For ball B. Okay, so now I write the equation again here. Now I'm gonna say that for ball B, what do I have? For ball B, my change in y, okay, my change in y for ball B equals the v initial times change in time plus a half a change in time squared. Remember they take the same time, ne? Okay, so my change in y for ball B, we got h minus what? We got h minus 9,62, right? What did I get? Yeah, h minus 9,62, okay. We got h, we got small height h minus 9,62. Okay. Now the v initial, because I chose up as positive, it's gonna be, and this was negative, ne? So ball B, they gave us the initial, which they said it is 8, okay. So I'm gonna make it negative 8 here. So this is negative 8, okay. N times t plus a half, okay. Then into negative 9,8, then t squared. So open brackets here, we're gonna have our h minus 9,62, okay, equals negative 8t, and then minus what? Minus 4,9, okay, 4,9 t squared, okay. And as you can see here, I can say that this 9,62 becomes positive this side, ne? So I can say that my h, small h, okay, equals to 9,62 positive now, because of course the equal sign, minus 8t, and then minus 4,9 t squared. So this is equation 2. Now equation 1 was saying h equals 13,8 t minus 4,9 t squared. What about equation 2? H equals 9,62 minus 8t minus 4,9t squared. So the two equations are equal. I can say equation 1 equals to equation 2. What does equation 1 say? 13, I have 13, 8t, okay, minus 4,9t squared. Now, because this is minus 4,9t squared, even here it appears, so it cancels out. Alright? The 4,9t squared in the two equations after being equated, it cancels out. So I'm going to have 10,8t equals 9,62 equals 9,62, then minus 8t. Okay, minus 8t. So the minus 8t becomes positive. So what is 13,8 plus 8? What is 13,8? 13,8 plus 8. It gives us 21,8. So I have 21,8t. I have 21,8t equals to 9,62. So divided by 21,8. So 9,62 divided by 21,8. What do we get here? 0,44. So our time t is what? 0,44. 0,44 here. So now we can get our small height h where they meet. That was the question. So our height h where they meet, using equation 1, we have 13,8 times t, which is 0,44. Okay. And then minus 4,9. And then what about our t? 0,44, but it must be squared. 0,44 squared. Okay. So our final answer is what? Let's check it out in the calculator. Calculator, please. 13,8, open bracket, 0,44, close bracket, minus 4,9, open bracket, 0,44 squared. What do you get? Here I get 5,12 as my answer. 5,12 meters. That's when the two balls meet each other. Hope we are together, guys. Next question here. What do they want? Draw a position time graph known to scale for the entire motion of objects A and object B on the same set of axes from the moment they are projected. Label the graphs and clearly indicate the following: height where the objects pass each other, time the objects pass each other as t. So position time graph for the two objects A and B. Are we together? Remember that one is coming from up, another is coming from down. Okay, if you check it again here, this one from up is B until the ground, also from A to the balcony. So they cover the same position actually. Okay, so in this case, our graph will look like this. Okay, our graph look like this. We're going to have our graph like this now. So in this case, I'm gonna say this is my y here. This is my y here. My y-axis, and then this is my time axis here. Now, because I want position time graph, I have change in y in meters. Okay, change in y in meters. This is time in seconds. Now, one object. Let me first. Yeah, one object in first put something like that. Okay, one object was from here. It came to the ground, so it moved like this. Not a straight line. Sorry. The cave. So down from the top, it comes like this. Okay, until it hits the ground. Then this other one starts from here, then it goes up, and they stop at the same height. If you check here, height must be the same. Okay, so this is where they meet. Okay, what must we indicate? The height where the objects pass each other. So this height, that's what we want. We got 5, what? Do you remember the answer? Was it 5,12 or 5,2? Let's check it here. Yes, we got 5,12. Okay, so that is 5,12 meters. Then the time, put there t. So this one here, we put our t here. All right, so this was object A. Let's check which one came from down. Is it A or B? A is from the ground. Okay, so this is for object A, and this is for B. All right, hope we are still together, guys. Don't get tired. Next question here. It says that this was from northwest here. Question 3, projectiles. Let's clean off the board here. Okay, they said that a painter is painting the tiles on the roof of a building. While painting the roller, he is using slips from his hand and poles from rest from the edge of the roof, which is 30 meters above the ground, as shown in the diagram below. So this is the building here. Ignore effects of air friction. Then they say, what is the magnitude and direction of the acceleration of the roller at the moment it falls from the edge of the roof at point X? I repeat, they say, what is the magnitude? What is the magnitude of and the direction of the acceleration of the roller at the moment it falls from the edge of the roof at point X? Now, the moment the roller falls from the roof, it becomes a projectile. Ne? So, being a projectile, they want magnitude of acceleration, which we said is what? It is g. We know the magnitude is what? 9. We say 9,80 meters per second squared. They said, and direction. Ne? So, direction we say downwards. We say what? Downwards. Okay. It is downwards. Next, calculate how long the roller took to fall from the roof at point X to the top of the window Y, which is 2,45 meters below the roof. Okay. We want to calculate how long. That's change in time. Okay. Which is 2,45 meters below the roof. Okay. That's point X out here. Now, because it is being dropped, our V initial is 0. Ne? V initial is what? Is 0. And from up to point, they said up to point what? From X up to what? They said that up to, okay, yeah, up to here. So we have the change in Y, we have the V initial, we're looking for how long, and we're gonna use what? We don't talk about final velocity here, ne? So I'm gonna use my change in Y because I have the 2,545 meters. So we take it down as positive, ne? So if we say that our change in Y, okay, we can say our change in Y equals to V initial, we're saying how long, no? Times change in time plus a half A change in time squared. So now the distance is 2,45 meters. We're taking down as positive. Now the V initial is 0 because we're from rest times t, which we're looking for, then plus a half times positive 9,8, okay, then times the time we're looking for, which is t squared. So here it's going to be now the 2,45, okay, equals to 0 plus what? Plus 4,9 t squared. So divide by 4,9 both sides. Divide by 4,9, okay. So 4,9 here, and then you square root. It gives us our t as, check it out there. We have 2,45 divided by what? By 4,9. It gives us here as 0,71. So our time is 0,71. So our time is what? 0,71 seconds. That's there. Therefore, the ball reach point Y. Okay. Then what else we need? Let's check it out now. They say the speed. Calculate the speed with which the roller passes by the bottom. Calculate the speed with which the roller passes by the bottom of the window at point Z. If the height of the window is 1,6, so I want the speed at point Z. Okay. Alright, now from the point x to z, I can see that I can get my height by adding the 1,6 plus 2,45. So I'm looking for the speed. Okay, looking for the speed. But because I know the velocity at point y and I know the change in time, do I know that? Let's check. What do I need? One more time, let's check it again. Calculate the speed with which the roller passes by the bottom of the window at point Z. Okay, at point Z. So, oh yeah, I better begin from X, because from X I know my V initial and I know my total distance from X to point Z. And yeah, I know that I can use that now. Looking for the V at point Z, so I can use V final squared. Okay, I can use what? I can use V final squared, okay, equals to V initial squared plus 2A change in Y, okay. So I'm looking for the V at Z, that's going to be V at Z squared. The V initial is 0, because it was released from x0, then plus 2A. Now the A is positive 9,8, okay. My change in Y is going to be what? 1,6 plus 2,45, okay. What do you get here? 1,6 plus 2,45. It gives me 4,05. I have 4,05 here. 4,05. So what's our final answer after finding the square root there? So square root of 2, okay, 2 multiplied by 9,8, okay, times 4,05. It gives us here 8,91. So that is 8,91. 8,91. So velocity here is 8,91. 8,91 here at Z, okay, 8,91 meters per second. Okay, then they say here what else must we find? They say a jogger running at a constant velocity of 7 meters per second on the ground below is 25 meters away when the roller falls. Will the roller hit the jogger or not? Support your answer, so we don't have to guess. They're saying that a jogger running at a constant velocity of 7 meters per second on the ground below is what? Is 25 meters away when the roller falls. Will the roller hit the jogger? Let's find out. Now, the logic behind here is that if the roller can reach the ground at the same instant when the jogger gets to the ground, then the roller will hit the jogger. However, if they take different times, then they won't collide. So I better find my time from the X up the ground. If I get that time, compared with the time of the jogger, 25 meters away to reach the bottom of the building. Okay, so here we go. Now the jogger is at a constant speed. They say it is what? It is 7 meters per second. Okay, let us find his time. Let us find his time. Now this jogger here, because moving at a constant speed, is not accelerating. So I'm gonna say that my change in x, okay, equals to v initial times change in time plus a half a change in time squared. Okay, change in time what squared? So now in this case, my change in x, they say 25 meters away. So 25 meters away. The speed was how much is his speed? Oh, come on. The speed of the jogger is 7. Okay, yeah, that is 7. So I'm gonna say 7 here. 7 times change in time, okay, which I don't know. Then plus a half a. Now the a is 0 because it's constant speed, then times change in time squared. Okay, so here I'm gonna have 25 divided by 7 equals to t, time by the jogger. Here. So what do you get there, guys? If I divide 25 by 7 here, divided by 7, I get 8,6, I mean 3,6. So this is 3,6 by the jog, or 3,57, 3,57 seconds. What about for the roller now? It's from rest covering 30 meters down. I'm gonna use again my change in y, okay, equals to v initial change in time plus a half, okay, a half change in time squared. So the change in y is 30 meters, okay. Now v initial was 0, so we're gonna make it 0 here, plus a half times a, which is 9,8, okay. What about, I'm looking for this time here, so this is gonna be now 30 equals to 4,9, okay. Then t squared, so divided by 4,9, so square root give us our t. Square root of 30 divided by what? By 4,9. What do we get? It gives us here 2,47. 2,47. So if you see properly, this equation 1, this equation 2, it shows that the times are different. Ne? So because the times are different, the roller will not hit the jogger. Hope we are together. Let us proceed. Next question here. They said that an object is projected upwards with a velocity of 14,7 meters per second. It returns to its starting point after 3 seconds. Draw a velocity time graph for the object's motion during the 3 seconds. Indicate initial velocity, final velocity, and times for entire motion on the graph. Okay. Alright, they said that an object is projected upwards with a velocity of what? 14 meters per second. It returns to its starting point after 3 seconds, which means it went up, then it came back down the same level. Draw velocity time graph for the object's motion during the 3 seconds. Okay, so here we go. During the 3 seconds. Okay, so in this case, we are going to have to draw. We need velocity time graph, ne? Okay. So we have the velocity on the y-axis. Okay. Okay. Now it's going up, ne? It's going up. If it is going up, we can choose up as positive, ne? We can choose what? Up as positive. We can choose up as positive, then it comes back, okay? Now if we choose up as positive, it means our V initial, which is 17, is going to be positive. It's going upwards, ne? Now we know that if the V initial is 17, it's going to be positive 14,7 here. Now the 14,7 being our V initial, and it's going upwards, okay? Because this is meters, ne? Velocity meters per second, ne? Okay. Now at maximum height, velocity is going to be 0. So we must know that in this case, our graph will be like this, then like this one here. Okay. Yeah, that's what we have here. So here it says maximum height because velocity here is 0. Now because to come to the same point, if this is positive 14,7, it must stop at negative 17,7 somewhere here. So this negative 14,7 when it is hitting the ground again, okay? They said for 3 seconds, so we're going to have our 3 seconds here. Yeah, that is it is 1,5 by time symmetry, which I hope you guys know properly. That's our graph. They say what else must we do? Use the graph to draw the distance covered by the object over 3 seconds period. Now, if I'm looking for the distance and I have a velocity time graph, note that we must find the area under the graph, ne? And distance being a scalar doesn't have direction, so I need this area here, guys. I need this area here together with this area here. So as you can see, these are triangles, ne? So to get my distance, I'm gonna say distance equals to area 1 plus what? Plus area 2. So how do you find the geometric a triangle? A half base times height, ne? But now there are 2 of them here. So I'm gonna say for area 1 and area 2, okay, it's going to be a half. Now my area 1 it is 1,5. What about my height? It is 14,7. Okay. What about my area 2? Also a half. Now from 1,5 to 3 is also 1,5, so that's 1,5 here as well. What about my height? It is negative 14, but because of distance, I only need I don't need the direction. I take magnitude. So I take 14,5. So this is 14,5. Maybe 14,7, not 5,7. Okay. All right. So my final answer here for the total distance covered is gonna be, let's check it out here. 0,5, that's a half, times 1,5 times 14,7. Remember there are two of them, so it gives us what? It gives me here 22,05. 22,05 meters. 0.05 meter, that's my answer there. Okay, let us move on. Our next question here, what does it say? Now this one is from Eastern Cape here. What does it say? Eastern Cape, they said that ball A is thrown vertically downwards from the top of the building 90 meters high at a velocity of 12 meters per second. At the same instant, a second identical ball will be thrown upwards at a velocity of 30 meters per second. Ball A and ball B pass each other after how many seconds? 2,135 seconds. Ignore air friction. You can see the diagram here. Give the direction of the acceleration of the ball B while moving upwards. Now ball B, although it's going upwards, acceleration is what? 9,8 meters per second squared, but downwards. So because they want direction, we only say downwards. We say it's downwards here. We say it is what? Downwards, okay? Okay, next question. They say calculate the velocity of ball B the moment it passes ball A. Calculate velocity of ball B the moment it passes ball A. Now the two balls meet after how many seconds? It 2,135 seconds. What do I want now? The distance ball A. I mean the velocity of ball B the moment it passes ball A. Now ball B is from the ground, whose initial velocity is 30. So I'm gonna take upwards as positive. I take up as what? Positive. So if I take up as positive for ball B, and I'm looking for the velocity when they pass each other, and I have the V initial, so I can talk about V final squared, right? Let's check it again. Velocity of ball B, that's V final when they're passing each other. So I'm gonna use V final squared, okay? I use V final squared equals to V initial squared plus 2A change in Y. No, I don't know change in Y. I'd rather use V final because I know the time. I'd rather use V final, okay, equals to V initial plus A change in time. So looking for the V final when ball B passes ball A. Now V initial is 30. I took up as positive. It's gonna be positive 30 here because upward is positive, and then plus A. So my G is gonna be negative 9,8. Now the time to pass each other was what? Was it 2, or 1, they said it is 2,135. So this is 2,135. 2,135. Okay. So what's our final answer here? Let's check it out. Let's check it out here. That's going to be 30 plus, open bracket, negative 9,8 times 2,135. What do I have? I get here 9,08. 9,08. Okay, 9, what? 9,08. 9,08 meters per second when they pass each other. That's for velocity for what? Ball B. Okay, next question. What do we need then? They say that that what? calculate the distance between ball A and B 2.5 seconds after the balls were projected. Distance between ball A and B 2.5 seconds after balls were what? Projected. So ball A is going down, ball B is going up. So after 2.5 seconds, where are the two balls? Then we're going to get how far are they from each other. Okay, so now with ball A, I'm looking for the distance. Ne? So I'm going to use change in y for ball A. Change in y for ball A equals to v initial plus change in time, plus a half A change in time squared. Now remember they gave me the time, ne? They said 2.5 seconds, ne? So now my v initial for ball A is what, guys? It is, I choose up as positive, ne? It's negative 12. So negative 12. What about my change in time? They gave us 2.5, so this is 2.5, and then plus a half. Okay. What about my acceleration? Negative 9.8, because I chose the up as positive. Change in time is what? Is 2.5. Okay, but must be squared. So my answer here is going to be what? Anybody with a calculator, you can help me out here. What do you get? What do we get here? What do we get here? Okay, calculator. If I check here, have open bracket, negative 12 times 2.5, then plus open bracket 0.5 times negative 9.8, then times 2.5 squared. Okay, which gives me negative 60.63. Negative 60.63. Negative 60.63. Okay, all right. Then now that's for my ball, for my what? My ball A after those seconds. What about ball B? Now change in y for ball B using the same formula equals to v initial times change in time, okay, plus a half a change in time squared. So we're going to have our v initial for ball B is positive 30 because we chose up as positive. Okay, the time they gave us 2.5, don't forget, 2.5 seconds plus a half. Okay, gravity we said up is going to be now negative 9.8 again. What about the time? It is 2.5 but squared. Okay, so what's going to be our answer here? Let's check it out. Open bracket, guys. That is 30 multiplied by 2.5, then plus open bracket, okay, 0.5 times negative 9.8 times 2.5 squared. What do we get? Here I get 44.38. I get 44.38. So that is 44.38 meters. Now this is my distance for ball B. Let's check it here. So ball B from the ground, it covers this distance, ne? Which is the 44.38. Okay, put somewhere here. That's for ball B. Then ball A from the top, okay, from the top, it covers this distance of 60.63. So from here, the 60.3, maybe it's somewhere here. Okay, somewhere here. So now I want how far are they from each other. What am I gonna do? I'm gonna get this distance from here where ball A has stopped and from the ground, ne? Given by 90 minus what? 90 minus 60.63. Okay, so this is 90 minus 60.63. Which answer do you get here? 90 minus 60.63. 90 minus 60.63. It gives me 29.37. So this is 29.37. 29.37. Okay. So now this was ball B. It reached 40 what? It reached 44.38. So how far they from each other? It's going to be 44.38 minus 29.37. What did you get? I said 44.38 minus 29.37, which gives me 15.1. So it is 15.01 meters from each other, distance apart. That's our answer. Hope we are together. Next here, they said that on the same set of axes, draw a sketch position time graphs of the motion of the balls A and B. For ball A, from the moment it was projected until it reached the ground. Then for ball B, from the moment it was projected until it passed the ball A. So these are two balls. Now for ball A is from the top until it reaches the ground. Then ball B until it passes ball A. Okay. So here we go. If you look at our balls here, you can see them here. Ball A from top to ground, ball B until reaching ball A. So we have our graph like this. Position time graph, okay? Okay, this one here like this. This is our change in Y, our position. That's our position here. Then our change in time here. So if I may start with this is change in time in seconds. This is position in meters, okay? In meters. If I start with ball from the top up to the ground, so it gets from here, from the top to the ground. Okay. What about this is ball A? What about ball B? From the ground until it meets ball A, so it comes from here and meets ball A somewhere here. So this is ball B. What must we indicate? Okay, this is where the time when the two pass each other. This is the height when they pass each other. This side here. What do they need? Let's check it again. Must indicate what? For ball A from the moment. Okay. What about for ball B? Okay, that is all we needed. We don't need any values. Okay. All right. But we got 15, what? Okay, no, that's from each other. Okay, no, it's fine. All right, guys. I think we can stop here. Please go finish up these questions. Thank you so much for watching. Or you can finish them up now. Let's check how many are left. Okay. Okay, let's finish them up anyway. Let us finish them up. This one here is from where? Let's check it. This was from Western Cape. Western Cape. They said that a ball A is projected vertically upwards from a height of 45 meters with a speed of 17 meters per second. 2 seconds after ball A is projected vertically upwards, a second identical ball will be thrown vertically upward from the ground with a speed of 18 meters per second. As in the diagram below, both balls undergo the free fall and eventually hit the ground. Define the term projectile. We said is what? It's a body given an initial velocity whose motion is only influenced by gravitational force. Next on the queue, calculate the time taken by ball A to reach its maximum height. Now, ball A to reach maximum height, we know the V initial, so we can choose up as positive. No? In that case, looking for the maximum height, where we know that velocity is going to be 0 at the maximum height here. V final is 0. Okay. So if I look at if I say V final squared, okay, equals to V initial squared plus 2a change in y. Now at maximum height velocity is 0, it's going to be 0 squared here. We chose up as positive, so it's positive 17, okay? But it must be what? Must be squared. And then plus 2a, acceleration negative 9,8 because we chose down as what? I mean up as positive. We're looking for the maximum height. That's h max. So this was the negative here. Then 19,6 h becomes positive this side. 19,68 equals to 17 squared. Okay. Our maximum height for ball A, get me the answer. This is 17 squared divided by 19,6. What do we get? Okay. 17 squared divided by 19,6. It gives us 14,74. We have 14,74 meters. That's our first answer for ball A. What else do we need now? Let's check out. Calculate maximum, we wanted time. Okay, yeah, maximum height, that's what it, now they want from the ground. That is the question here, from the ground. So to answer this question of 3.2.2, our answer which we got here, we're going to say plus 45. Okay, so I'm going to come back and do this question here. I thought that's what they wanted. So here, maximum height from the above the ground for ball A is going to be the 45, okay, meters plus what? Plus 14,74, which gives me what? Let's check it out here. That is 45 plus 14,74. I get 59,74. So that is 59,74. 59,74 meters above the ground. Okay. Now here there is a time taken to reach maximum height by ball A. Because I know the V initial, I'm gonna use V final equals to V initial plus a change in time. Okay. So at maximum height, final velocity is 0. V initial was 17. We said positive because we chose up as positive. Okay. What about our acceleration? We said negative 9,8. We're looking for this time to reach maximum height. Okay. So we're going to have positive 9,8 after crossing the equal sign. T equals to 17. So divided by 9,8. What do you get as our answer here? 17 divided by 9,8. 17 divided by 9,8. It gives me 1,73. 1,73 seconds. That's our answer here. Time is what? 1,73 to reach maximum height. Okay. Then there's a calculate velocity of ball B when ball A passes its original position on its way down. I repeat, calculate the velocity of ball B when ball A passes its original position on its way down. So for me to get the velocity of ball B, I need the time at that for this ball B. So that time will be the same time taken by ball A after passing the original position here, somewhere here. So it means the time to reach maximum height at the same time from maximum height to the same original position. In other words, I'm going to multiply this time by 2. I'm using time symmetry. So the time covered by ball B that is required in the question is going to be 2 times 1,73. 2 times 1,73. 2 times 1,73. So to get the velocity which I want here, I'm gonna say time covered by ball B by then is gonna be 2 times 1,73. Okay, which answer do you get here? Calculators. 2 times 1,73. It gives me 3,46. This is 3,46. 3,46. 3,46. Now I want the velocity for ball B. I know the initial is 18. So the second velocity of ball B, yes. So I'm looking for the V final. So I'm gonna say V final equals to V initial plus a change in time. V final for ball B, okay. The V initial, I know it is 18, and I chose up as positive, plus negative 9,8. The change in time we got 3,46. So my velocity for final for ball B is going to be which answer here? Calculators, check it out. We have 18, okay, plus open bracket, negative 9,8 times 3,46. It gives us what? Negative 15,91. Negative 15,91 meters per second. Because they want velocity, it must have what? This magnitude and direction. So the negative here, remember, chose up as positive. It means it's going to be downwards. So it's going to be now 15,91 meters per second downwards. That's our answer. What else do they need now? That's all. Now the Cape Wine Lines trial 2024 question 3. They say that a group of learners set up an experiment to determine the height of their school. They release a tennis ball from point A at the edge of the roof of the school building as shown in the diagram below. Better make it bigger, right? The diagram below, okay. Then point B is 2 meters above the ground, and the ball takes 0.15 seconds to cover distance from B to the point C. That's the time taken, okay. Write down the magnitude of the rate of change of velocity of the ball. Now this is the acceleration. What's its magnitude? 9,8 meters per second squared. So our answer is what? 9, what magnitude? No? It's 9,8 meters per second squared. Okay. Next, they say calculate the height h. Calculate the height h of the school building. Now I'm looking for this height h. What do I do? Now the balls were from resting. Let's check again. They release. Okay, that means the V initial is 0. I want the height h here. What do I know? They say this is 2 meters here. What do I know? I need to get my height. So because I don't know the velocity to reach the ground, but I know the change in y here, so I better find my velocity at B. When I get my velocity at B, together with the V initial as 0, I can find this height from A to B. Then I add that height to 2, and then I'll be having the answer. I repeat, because I know the time to cover the 2 meters here, and I know these are 2 meters, I can find my velocity at point B. After getting it, later I use V initial at A with velocity at B as my final to get my height AB. Then I say plus 2. So here we go. So in this case, I'm gonna use change in y. Okay, change in y. That's between B and C. Okay, equals the velocity at B, which we call a V initial here. Velocity at B times change in time, okay, then plus a half a change in time squared. So I'm gonna say the change in y, this is 2. Okay, now I'm taking it down as positive. Now this is 2 meters. Then I'm looking for the velocity at B. Okay, the time given was 0, what here? 0,125, 0,125, then plus a half. Okay, I took down as positive. That's 9,8 here. The time is what? The time is 0,125, 0,125. That must be squared. So now this 2 minus this, what do we get? And then later divide by that. Okay, so calculators, take them out. You're gonna say 2 minus open bracket 0,5 times 9,8. Okay, then times 0,125 squared, close bracket. What do you get? Okay, then later divide by what? By 0,125, 0,125 to get our answer directly. So it gives me 15,39. So this is velocity at B. Velocity at B is 15,39. So this is 15 here, 15,39. Okay, so now I know it here V initial is 0. Okay, I can get this height now by using V final squared. I can say V final squared equals to what? Equals V initial squared plus 2A plus 2A change in Y, which I'm looking for. That's from A to B. From A to B. So V final here kiona 15, what? 15,39. Okay, squared. What about V initial? It was 0 at point A plus 2A. This is positive 9,8. Okay. I'm looking for the height from A to B. That's why from A to B. Okay. So I'm gonna square this, then divide by 19,6, and that's gonna my Y at B, AB. So I'm gonna say that 15,39 squared, okay, divided by 19,6 to get my YAB, which is 12,08. So my YAB from here, distance between A and B, it is what here? It gives me 12,0 what? 0.08. Now I want the total height, so I'm gonna say plus 2, which is gonna be 14. So I wanted the height of the school. It's gonna be now 14,08. Okay, hope we are together. Let us finish up this. Then the set time it takes for the ball to reach the ground. Because I know the height and I know the initial, I can find my time to reach the what? To reach the ground. What do I use? I'm going to use change in Y again. Okay. I'm gonna use what? Because I don't know if I know velocity to reach the ground. So I'm gonna use change in Y again. Change in Y equals to V initial times change in time. Okay. Times change in time. Plus what? Plus I have A change in time squared. So the change in Y is 14, what? 14,08. My V initial was 0 times change in time, give me 0 plus this is positive 9,8. Okay, looking for this time here. So this is 14,8 divided by 4,9, then square root. So my time is gonna be time given by square root, okay, of 14, what, 0.08 divided by 4,9. Okay, which answer do you get here? Calculators. Which answer do you get here? Square root of 14,08 divided by 4,9. It gives us 1,70. 1,70. Okay, then lastly, calculate the velocity with which the ball strikes the ground. And now I need the V final. Because I have the V initial, I can say V final equals V initial plus A change in time. So V initial was 0. What about our gravity? 9,8. What about our change in time? We got now what? We go to 1,7. So 1,7 here. Okay, so what's the final answer there? We are gonna say that 9,8 times 1,7, which gives us 16,66. 16,66 meters per second. Okay, hope we are together. Then they say here, sketch position versus time graph for the motion of the ball from the moment it was released until it strikes the ground. Use the ground as zero reference. Okay, indicate the following: the height from which the ball was released, time when ball strikes the ground. Okay, now this ball is from this is they want what? Position versus time graph, ne? Okay, no problem. So why not? Because it's going downwards and is accelerating. If this is our y-axis, okay, for the position, that's our y for the position, then time here on the x-axis, okay, then it will come like this. What was accelerating? Okay, what must we indicate? Height. What was our height? We got it already. Then the time, okay, time we got 1,7, so this is 1,7 here. This is time in seconds. This is change in y in meters. What was our height? What did we get? 14, something. Remember 14,08 here. So it is 14,08. 14,08. Okay, next, our last question for today. Last question here. It says what? This is from Limpopo. Limpopo, guys, how are you? Yeah, question says that a ball is dropped from a height of 20 meters and it rebounds with a velocity which is three quarters of the velocity with which it hits the ground. The ball bounces 2 times as shown in the position versus time graph below. What must we do? They say here that the effects of air resistance and the time elapsed with the ground are neglected. They find the term free fall. Now, free fall is motion of a body which is what? Influenced only by the force of gravity. Next, state acceleration of the ball the instant it reaches maximum height after the first bounce. Now, this ball is a projectile, so it must be 9,8 meters per second squared downwards. That's our acceleration. Then 3.3, calculate the time interval between the first and second bounces, that is TAB, by using the equations of motion. We want this time here, the time interval between what? Between A and B. So I must find the time to reach what? To reach point A first. Then from here, time to reach point P. Then I can find time between A and B. Okay. What do we know? They said that a ball is being dropped. So V initial is 0. So we have our change in y, and also we have the initial velocity. So we can get our change in time to reach point A. So here we go. What do we say then? We can use our change in y, okay? Change in y equals to V initial change in time, okay? Plus a half a change in time squared, okay? So the change in y, they gave us 20, so we're gonna say 20 here. The V initial is 0, 2 times time which we are looking for, plus a half a, that's 9,8, okay? We're looking for this time here, t squared. Now this time is to get from O to A. From O to N. So this is 20 divided by 4,9, okay, to give us our t squared. That's from where? From O to A. From O to A. So we'll then find the square root to give us that time. If we check it now, it's gonna be square root of 20 divided by 4,9 divided by 4,9, which gives us what? It gives us 2,02. So time from O to A is 2, what? 2,02. Now I need to get time from A to P, but before that, I need to first find the velocity when I'm hitting the ground, so that I can find the velocity for bouncing. Okay. Now I have the V initial, I have the time, so I can use V final, okay, equals to V initial plus A changing time. So v final is what I'm looking for to hit the ground. I'm gonna say v final. V initial was 0, okay, plus a, which is 9,8. Now the time is the 2,02. Okay, so what's my v final gonna be? So 2,02 times 9,8. 2,02 times 9,8. So it gives me 19,80. I get 19,80. Now they said that velocity of bouncing is 3/4 of the velocity with which we hit the ground. So the velocity from at point A going upwards is gonna be my v initial in this case. Okay, it's gonna be 3/4. That means 3/4 times what I have here times 19,80. 19,80. So what do we get here? 3/4 times 19,80. It gives me 14,85. So yeah, I have 14,85. Now that's the velocity from bouncing. Ne? Now at maximum height here, velocity is 0, right? So I can get time to get there. So I'm gonna use v final, okay, equals to v initial plus a change in time. So v final at maximum height is 0, okay. My v initial is this 14,85. Then plus a. Remember that I chose down as positive, no? So we get down negative 9,8. Now I'm getting the time from A to P, So this gonna be now when negative 9,8 becomes positive this side, ne? So I better say positive 9,8. Then T A to P, okay, T A to P equals to 14,85. 14,85, and then divide by what? By 9,8. So I get my time from A to P as what? Divided by 9,8. Okay. It gives me here 1,52. 1,52. So now, meaning that what? The time from A to P is 1,52. Now from P to B will be the same time because of time symmetry. So 1,52 times 2, what do I get? Times 2, it gives me 3,03. Meaning from A to B is going to be 3,03. 3, what? 03. 3,03, that's my answer, I guess. Let's check. 3,03, what's going to be which time? Let's check what they want here. They want the time interval. Yes. So my time interval between A to B, okay, is going to be 2 multiplied by 1,52, okay, which gives me here 3,03. 3,03 seconds, okay. All right. What must I sketch again? They said that sketch a velocity versus time graph for the motion of the ball from the instant it is dropped until it reaches maximum height after the first bounce. Indicate the following: the times A and P, velocity with which it hits the ground, velocity with which it rebounds. Okay, no problem, guys. Now I want a velocity versus time graph. This ball was being released, okay, meaning v initial is 0, okay. Then it hit the ground, okay. So remember that I chose down as positive, ne? So mean that we need, which means I'm gonna do like this now. I'm gonna do like this one here. So if I have my y-axis like this, okay, this is my y-axis here, okay, and then I draw this line here, the time axis, time axis there. And then I'm gonna draw velocity time graph next. So this is my velocity here in meters per second. This is 0 here. So because it was from resting and down is positive, it means it must move up like this now. So this is my velocity for hitting the ground. Okay. And then that velocity, I know the value here. Then now it lost some of the velocity and rebounded somewhere here. Now from there, it goes to maximum height. And where it's supposed to stop? Let's check again. Now these lines must be parallel. They must be parallel. They must be parallel. Okay. All right. Let's check what we need here. So, yeah, I ignore the time of contact. Okay. This is time in seconds. They say what must we indicate? The times at A and P. Times at A and P. Now at A it is 2,02. 2,0, that's when we hit the what? The ground. 2,02 here. 2,02. At P we reach maximum height after 1,52. So 1,52 is when you add to 2,02. So 2,02 plus 1,52, 2,02 plus 1,52. It gives me 3,54. So this is 3,54. Okay. What must I indicate else? Velocity. Velocity with which they hit the ground. What did we get? Remember we got something here. We got 19,880. So this is 19,80. This one here, 19,80. 19,80. What about here? Do they want it also? This velocity for bouncing. After multiplying by 3/4, let's check it out. 14,85. 14,85. Yes. 14,85. This is 14,85. Yeah. Alright guys, this is velocity meters per second. Okay, they said let's check what they wanted again one more time. From the instant it dropped until it reaches maximum height after the first bump. So it means we don't want this part of the graph. So this one we don't want it. Oh, okay, so you only want this one here. I want this one here. From here to maximum height, so I must stop here. Yeah, that is it guys. Alright, thank you so much for watching. My name is Patrick Kamala, tutor, educator for mathematics and physical sciences at Roster College Polokwane. Talk to you again in our next video. Bye bye.